Hey everybody, welcome back to our week 13 graduate statistics. This is lab 13, that's video 2. We are working with this data set, trying to figure out how to get a sense or predict current milk production, considering some variables that we can collect about the herd, about the milk, about the previous month production. And this is a way of exploring the data set. Like I said, I'm playing the naive analyst. I understand nothing about milk production. I was given this data set and I want to figure out and explore what are potentially hopeful predictors of current milk production. But I want to walk you through this plot. So here we have the various variables. Here is the response variable. Here's all of our numerical predictors, previous month production, some characteristics of the milk, fat and protein in the milk, and some characteristics of the cattle, days after current lactation, either a continuous variable that assesses it or a categorical variable that kind of breaks it into prior to 79, less than 79 days or more than 79 days. Lactation, number of lactations in total. So this diagonal here would be kind of useless if you did scatter plot or if I got a correlation coefficient, because the correlation coefficient would be 1 and we would have like this line of points right in the middle, because it would be a perfect correlation if we create a scatter plot of a variable with itself. Here's current milk, here's current milk. All right, so instead what the function ggpairs does is to create the distributions of these variables, right? That's the distribution of current milk, that's the distribution of previous milk production, fat, protein, days, lactation, and because I-79 is actually a categorical variable, you can't create sort of a density plot like this. So it has sort of a histogram showing how many of the observations have the cattle on average with less than 79 days since last lactation and number with more than 79 days. So we have many more of that observation than that, which is a little bit problematic, but we'll ignore that for now. So we would want that to be kind of divided equally, but we'll not worry about it for our purposes. Then, given that I am completely naive in this topic, I would be looking for scatter plots that look promising in terms of really looking at, because this is the one we want to predict, so how the other variables relate to current milk, all right, production. So I am looking at these scatter plots, and the first one looks sort of promising because it shows like a positive relationship that I would say would be potentially moderate. There are some kind of points going down here, kind of creating a bit of spread. So not super duper strong, but you know, it's a clear trend upwards. And that's the relationship between current milk production and previous milk production. So if you know something about the prior month's production, apparently it looks like you can know a bit about what's going to happen this month, right? Because there seems to be a correlation between the two. If I want to know the exact correlation, let's look at the number on the other side. So here we have the current milk production, and we're going to look at the correlation with the previous milk production, and we're looking at a 0.75 correlation, right? Given that this is a pretty complex thing to predict, right? So how much milk I'm going to produce, 0.75 seems good. Let's see what other variables are there that might be helpful in enhancing our ability to predict what current milk production will be. If you look at these scatter plots, the other one that seems to be interesting is this one here that shows the relationship between days after lactation and current milk production. The relationship there, though, is kind of on the negative end, and it seems to be weaker in this one. See how the cloud is more spread around? But there is a clear kind of trend downwards here, which suggests that the more days passes since lactation, the less milk the herd tends to produce in the current month. So if you know, here's my herd, what's the average number of days after lactation that my cows have, that will be related to the current milk production in a negative fashion, meaning the most days have passed since the cow began lactating, the less milk production we'll see, which kind of makes sense, right? When the calf is kind of weaning and stopping to breastfeed, the amount of milk production reduces. Yes? So this looks interesting. Now, if I want to know the relationship between current milk and this categorical variable here, what R does, because it's categorical, it doesn't make sense to create scatter plots. So what it does, it creates a distribution of current milk production for I-79 when it's coded 0, right? It's either 0 or 1. 0 means less than 79 days. And you can see how that spread is more to the right. It's closer to higher milk production. And it's more, the peak will be more towards the left for when production of milk is from cows that have more than 79 days. A better way to get a glance on this is to look at the relationship between current milk and I-79 here, because again, you don't have a number for correlation because it's one categorical variable and one continuous. So what it does, it plots two box plots, and we can see how the median milk production for a herd with an average time since lactation that's less than 79 days being higher than for a herd that has that has more than 79 days since lactation, right here. Does that make sense? So when it's a categorical variable with a continuous variable, instead of providing a correlation coefficient, it shows the difference in current milk production between these two levels of the categorical variable, which makes sense. And instead of the scatter plot, it plots the distribution of the variables for each level of the categorical variable. And we're seeing here, the median would be kind of towards higher milk production. The median here would be towards lower milk production, which is kind of clear around here. Yes? All right. What else are we seeing that is promising? Not very much. It seems that the relationship with protein, there is a negative slant here. If we look at protein and current milk production, there is a correlation there, but it's not as strong, definitely, than the relationship with the previous milk production. That's a good bet for us to use as a predictor of current production. And also, the days since last lactation seem to be an important one. And we can use kind of the categorical variable to sort of get a cutoff and say, use a categorical variable and a continuous variable in the model. So we can choose either one of the two. All right? So because today in class we talked about models with a continuous and a categorical variable, we'll kind of work with that in mind and kind of try to reproduce the logic that we've seen in class. And then next lab, we'll do two continuous variables so you can see how it differs, but it's actually a little simpler when you have two continuous variables in a way. That's why I'm mixing them up, so you guys can think about models when you have a mix of types of variables as predictors. All right. So when I'm looking at these correlations, I would consider correlations of magnitudes 0.20 and higher as a general rule, especially because I'm seeing some much higher ones. And here, what I've just talked you through is written right there, right? So relationships between possible predictors and response variable of interest. So I saw that previous month milk production is highly correlated with current milk production, 0.785. This correlation coefficient suggests that the higher the milk production in the previous month, the higher the production can be expected to be in the current month. So if things went badly last month, the tendency for it to continue to go bad. But it is also modified by other stuff, like the number of days since present lactation. That is negatively and moderately correlated with current production. The R is negative 0.48. As expected, a similar pattern, though of smaller magnitude, is observed between current milk production and the variable I79, the categorical variable. So we're seeing a difference in milk production between level 0 of that variable, less than 0.79. You have more milk production there, and less milk production when it's more than 79. So same pattern. This variable is categorical and equal to 0 when there is less than 79 days passed since present lactation, and 1 when more than 79 days have passed. Current production is also negatively, though more weakly, correlated with the percent protein in the milk. That's negative 0.35. Other predictors seem to correlate more poorly with current production and are not likely to be helpful predictors. At least not as helpful. So let's focus on the 2 best predictors, easy to measure, right? So if you keep track, if you tell your guy, your boss, we can get a better handle on what our production will be this month. If we, let's say if the model works, if we just keep track, close track on how much we produced of milk last time, and if we make, record of the days after present lactation. So as soon as the cow starts to lactate, we register that date, so we always have the number of days since present lactation, so we can get an average number of days, so we can predict, use that as a predictor of how much milk we can produce that month. So let's pick these 2 because they're easy, much easier than convincing your boss to measure the protein, the amount of protein in the milk, and the correlation there is a little bit lower. Let's see how far we can get with these 2. Okay? So this is more or less how I think as a data analyst when people come to me with data sets on topics that I don't understand much. But then the person might say, no, we actually have technology. We always measure protein in the milk on our farm, so I would include that too. But this is, I'm trying to just think, what's the simplest types of variables that I can easily help my client, which is you, convince your boss that those are simple metrics that we can take that will give us a better grasp on what our production will be each month, which will help us plan, budget, what will happen, so on and so forth. Yes? Good. So what I want to say, when you look at here, it's printing this thing on mine. I'm not sure if we'll do the same in RStudio Cloud. I don't know what that is. It's basically telling you how long it took to plot each one of the plots. I don't think that's really important, but I don't know how to omit. I tried, but I couldn't figure out how to omit that piece. But this plot is important in guiding us in the choice of predictors, especially if you have no conceptual understanding of that field and you don't have a particular interest in any one of the variables. Okay? All right. Let's focus on these best predictors then, previous milk production and days since last lactation. There are 2 options here for us in terms of picking variables. We can pick days, which is a continuous variable, or we can pick I79, which is a categorical variable, and create a correlation plot with only those, right? Let's use both for now. So let's create the same correlation plots, but let's leave out the columns that do not interest us. So we just have current milk production, previous milk production, days, numerical variable counting days after first present lactation, and 7, which is the I79 categorical variable. Here we're picking the size of both, the size of the printing of the correlation, and the other one picks the size of those labels. See how I played with the size? Because if I used the same 40 and 35, it blew out of proportion, so I had to reduce those. So let's plot. It takes a little bit. There you have it. We can ignore this first part, so now it's more compact, only with the variables that we want. We can see current milk production very nice here relating to previous milk production. And we are seeing this negative relationship between current milk production and days. And we can also see nicely the difference between the category 0 of our variable I-79, which is the category of the herd producing, having on average days after lactation less than 79, and here more than 79. So when you have more, your cattle has on average more than 79 days, you have less production on average than if you have your cows have just lactated on average. All right. Relationship between candidate predictors. So this is important too. So our candidate predictors should not be super duper strongly correlated, because if they are basically one and the same thing, then you will make your model not very stable. What we're seeing here is that predictor, previous, and days, let's say days is here, oh, and previous and days, right there. There is a correlation, but the correlation between previous and days is not super duper strong, so it's okay for them to be in the same model. If you saw a correlation of 0.8 and above, I would be really careful including both in the same model, right? Then you have to reason through which one should I include, which one should be, make more sense conceptually to be included, but not both of them. The last thing I'll do that makes it interesting, I think, is to use this categorical variable I-79 to sort of color the dots so that we can begin to understand the relationship between current and previous milk production depending on the amount of time that the cattle has had the last lactation, the present lactation. So we'll color each level of the variable I-79 a different color. So I'm adding this mapping variable here as an input to the ggpairs. I'm mapping color to the variable I-79. And when I do that, what we have is this nice thing here. So when we look at the overlap between current milk and I-79, so when you look at the distribution of current milk, it's now separated by the level 0 of the variable I-79 and the level 1 of the variable I-79. So you see how the level 1, the distribution's peak, implicates less milk production than the distribution in red. That is kind of mapping with this difference between the two. So you get, if your cows have just begun lactating, you get more milk than if they're towards the end of their lactation. And if we look at the relationship between current and previous milk, the relationship seems to be preserved for both level 0 and level 1. However, it's interesting to see that current milk production tends to be higher. See, current milk is in this axis and previous is here. And we can see how you have higher values for I-79 than for the I-79 equals 0, cows that just began lactating, versus cows that are lactating for a long time. So you can see how, maybe you're going to need two different models, two different lines to represent these two different levels of the categorical variable, represent the relationship between current and previous for these two levels of the categorical variable. Just like we've seen in class when we correlated the volume of books with their weight separately for hardcover books and paperback books. All right, so we're doing the same logic here. All right. When we come back, we'll dig deeper to identify potential predictors by guaranteeing. So we just want to use predictors that not only have a high correlation coefficient, but statistically reliable coefficients. So you want to look at these p-values just to guarantee that the correlation is statistically significant before we start building our multiple regression models. Okay? So come back in a bit and talk about that. See you soon.